Good morning and most welcome to 1293. Yes, indeed. We do have sunshine. What else can you want? I will continue with a beginner's guide to mathematical constructivism. And we've gone through Toralf Skolem, Hilbert, Kronecker, and now we're getting more and more into Brouwer. However, and I continue directly where I left off in 1292. However, the idea has motivated some to investigate the basic arithmetical operations in terms of their actualist, finitist, or transfinite nature. R. Parik has indicated in 1971. By technical results that there is a substantial difference in character between addition and multiplication on the one hand and exponentiation on the other. Now, predicativism. It is a school a bit older than the above two. It might be the first more specific offshoot of constructivism and a forerunner of intuitionism. It is closely associated with the figure of the renowned French mathematician Henri Poincaré. Poincaré's input into the discussion about the foundations of mathematics is significant for two reasons. First, he was one of the first to indicate the key role that the intuition has in mathematics. In particular, the intuition of pure number, as he called it. This intuition justifies the principle of induction on the naturals. This means that he believed that this principle is a priori synthetic. That is neither tautological, that is justified by pure logic, nor empirical. It stems, he believed, from our basic intuitive understanding of the notion of number. Hence, Poincaré allowed for potential infinity of naturals. In this respect, he fully agrees with Brouwer. Second, he had a sensible and interesting idea about the cause of set-theoretic paradoxes. According to him, they were due to impredicative definitions which trigger a vicious circle. An impredicative definition is such that defines an object O by referring to a totality S whose O is simultaneously a member. His example of impredicativity in the motion was the Richards paradox. Let S be the totality of all real numbers given by infinite decimal fractions, definable in finitely many words. S is countable, so by Cantor's diagonal argument, one can define a real number O that is not an element of S, but O has been defined in finitely many words. Here Poincaré indicates that the definition of O as an element of S refers to S itself and is therefore impredicative. Predicativism may be described as constructivism with respect to definitions of sets. Sets are constructed from below, not by singling them out from a greater totality conceived as an existing previously. Poincaré's foundational ideas have inspired semi-intuitionists and can be found in the following publications: La philosophie mathématique d'Henri Poincaré, and a book by Poincaré himself, Science and Hypothesis. Now let's go over to intuitionism. If it wasn't for the foundations of mathematics and computer science originating from the research in finitism, intuitionism would probably be the most prolific and influential school of thought among the constructivists. Nevertheless, it is a position with a serious philosophical background that attracted various logicians and mathematicians who sought for more than a methodological rationale for mathematical practice. And indeed, intuitionism prides itself on likely the most developed and consistent among all of the discussed positions. Leutzen Egevertus Jan Brouwer was the founder of intuitionism. It seems to me that his foundational stance is a direct extension of his broader philosophical view. He expressed it in a short essay entitled Life, Art and Mysticism, articulating a deeply pessimistic worldview soaked in solipsism, epistemic anti-realism, and stressing the importance of the individual. In his work, he stated that mathematical enterprise is one of the ways to freeing oneself from the bounds of the mundane and worldly. The individual can commit to mathematical endeavor thanks to the intuition of certain mathematical objects, which underlies entire mathematics, he believed. Some critics of Brouwer argue that his idea of a cognizing subject, the idealized mathematician, is described like some kind of a mystic connecting to the realm of mathematics, and it is understandable given Brouwer's philosophical tenets in his philosophy of mathematics, which he called intuitionists' acts. As follows. Mathematics is not formal. The objects of mathematics are mental constructions in the mind of the ideal mathematician. Only the thought construction of the idealized mathematician are exact. Mathematics is independent of the experience of the outside world, and it is in principle also independent of language. Communication by language may serve to suggest thought constructions to others, but there is no guarantee that these constructions are the same. Mathematics does not depend on logic. On the contrary, logic is part of mathematics. It should be noted that Bohr met with Brouwer. So he was the top-notch among the mathematicians of his time. We see how radically Brouwer rejected both formalism and logicism. He explicitly repudiated the main principles of these positions. More than that, the separation goes deeper, as the revised formalism of the post-Gödelian times, which claim that mathematics is just some sort of language. It is also clearly anticipated and rejected On the other hand, Platonism of any kind is similarly cut off. Since the existence of mathematical objects depends on their being constructed, thus they are not eternal and independent of the mind. When Brouwer formed his intuitionist views, he was still a practicing topologist, and only a couple of years later did he realize that his stance required the revision of classical mathematics along with its logic. The consequence was the rejection of law of excluded middle and its classical equivalent, the principle of double negation. And with them, of course, the method of proving contradiction. The reason was that, say, we know that the statement P does not hold. The intuitionist claim is that with only that knowledge we cannot conclude that P holds, since we do not have a constructive proof of the latter. Regarding the mentioned concept of intuition, Brouwer explains that our mathematical intuition comes from the intuition of time. Mathematics is an activity of the mind having its origin in the perception of a move of time. That is, of the falling apart of a life moment into two distinct things, one of which gives way to the other, but is retained by memory. If the tuity thus born is divested of all quality, there remains the empty form of the common substratum of all tuities. It is this common substratum, this empty form, which is the basic intuition of mathematics. And he adds, this empty tuity and the two unities of which it is composed constitute the basic mathematical systems. One could say that this idea of tuity founds the structure of ever proceeding numbers. That is the naturals. So we see that here infinity is also regarded only potentially. On the other hand, agreeing with Poincaré, the principle of induction on naturals is fully acceptable from an intuitionist point of view. When it comes to the real numbers, according to Brouwer, human mind cannot ever construct a totality like a continuum. The continuum as a whole was intuitively given to us. A construction of a continuum, an act which would create all its parts as individualized by the mathematical intuition, is unthinkable and impossible. The mathematical intuition is not capable of creating other than countable quantities in an individualized way. The idealized mathematician, the key part of the philosophical landscape of intuitionism, is a curious thing. I believe that there is a very neat idea to reconcile realism and anti-realism in philosophy of mathematics. On the one hand, Brouwer stressed that mathematics is a free activity of the mind and completely depends on the mental constructions of the subject. So it was common to hear realist critiques that his intuitionism relativizes mathematical truth and leaves it to the whim of a mathematician. But on the other hand, the idealized mathematician is in a way an ultimately rational creature, or should be understood as mathematical knowledge of humanity as a whole. So, by that disclaimer, Brewer ensures that mental constructions of such idealized subjects are determined to capture what's mathematically true. Hence, summing up, we could describe the intuitionism cognizing subject to be fully free to construct whatever she wants, but she is destined to construct only the correct constructions. Like a God who is volitionally free, but only do what's right. Well, though I believe I have some substantial literature to back this up, this is still my interpretation of Brewer. So there could be some inconsistencies in my writing. And however strange, captivating and deep intuitionistic philosophy is, it would probably not last longer than until the 40s if it wasn't for Brewer's doctoral student and developer of the intuitionist program. This might be one of the stronger arguments against the non-distinctiveness and eternalism of time, because as Brewer himself wrote, mathematics comes out of the flow of time. It's not too hard to see, and possibly it is most clearest when it comes to the ordinals. The first, the second, the third, the fourth, protos, deftero, triti. You see, in the ordinal time is everything, and it's only time that can give order. You see here, it's an indirect critique of presentism or eternalism and this underlying idea of, how can you say that? Idea of everything already lying out there, already being finished, nothing else to add, which is presentism and eternalism. That in itself would not make mathematics possible, because without the flow of time, how would you tell which number comes first, which comes second, which comes third? And that is, I think, a very big problem in Greek thinking. They seem to neglect what they themselves are doing. It's a sort of forgetfulness. This forgetfulness makes a foundation, and on top of that, the philosophical thinking and problems and conclusions are created. But they can never ever go back to the start, because the start has hidden itself. It is not understandable by the knowing which is above, because that knowing, that understanding is ontic, can only see beings. It is the understanding itself that is defined by what is lying below. Therein lies the conundrum. And for me personally, this is the greatest explanation why no one ever took up the question of being. Until Heidegger and Wittgenstein. Being was gone from the view. Being wasn't something you could discuss, because the question could not be formulated. The only question that were possible was beings with little b, and then we can only ask what they are, how they are, how many they are, and so on, but not why they are, which is a completely different question. The why is a modus, it's a Stimmung. And this is an invitation to get into another Stimmung, another way of understanding. Not the content of the thinking, but the way of the thinking. It is turning the tables, learning that another way of understanding is around the corner. It is something that we can reach out to. Of course, it's helpful to have different approaches, like the more philosophical by Roberto Unger, complemented by Lee Smolin, more scientific and sharper, and now from constructivist mathematics, because the problem cannot be defined, and it shouldn't be defined, not in the ordinary way, because that would once more create beings rather than being. I also found this book by Filippo Casati and Daniel O. Dahlström, Heidegger on Logic. Be mighty interesting if the concept of time is in here, that the flow of time is what creates logic, because it stands in the order. Without time there can be no logic. If everything is put on an equal footing, how could we have a syllogism which is ordered, and order comes in time? Why, thank you very much, and have a very pleasant afternoon, I think it is. Let's see if I can get some of that snow into the